So let's just start chapter number 5, which is time units. The level property is pretty self-explanatory. Later on, when we create a battle system, zombies who win more battles will level up over the time and get access to more abilities. The ready time property required a bit more explanation. The goal is to add a cooldown period, amount of time a zombie has to wait after feeding or attacking before it's allowed to feed attack again. Without this, the zombie could attack and multiply 1000 times per day, which would make the game way too easy. In order to keep track how much time a zombie has to wait until it can attack again, we can use Solidity time units. Time units Solidity provides some native units for dealing with time. The variable now will return the current Unix timestamp of the latest block, the number of seconds that have passed since January 1st, 1970. The Unix time as I write this is the Unix timestamp. Unix time traditionally stored in 32-bit number. This will lead to the year 2038 problem when 32-bit Unix timestamp will overflow or break a lot of legacy systems. So if we wanted our DF to keep running 20 years from now, we could use 64-bit number instead, but our users would have to spend more gas to use our DF in the meantime. So it's a design decision. Solidity also contains the time units: seconds, minutes, hours, days, weeks, and years. These will convert a unit of number of seconds in the length of time. So 1 minute is 60, 1 hour is 3,600, 60 seconds multiply 60 minutes. 1 day is 86,400, 24 hours into 60 minutes into 60 seconds, etc. Here's an example of how these times units can be useful. Okay, let's see. Here it is. Here we have declared a variable last update joined set last update to go now will return true if 5 minutes have passed since the updated time, and was called false if 5 minutes have not passed. So here we are uh, just checking the uh, condition and returning that last updated plus 5 minutes, adding the 5 minutes to the last updated, and if it's greater than equal to if 5 minutes have passed since update times was called true was called, then if false if 5 minutes have not passed. So that's how we can add minutes into our Unix timestamp. We can use these time units for our zombie cooldown feature. Let's add cooldown time to our DF and make it so zombie have wait 1 day after attacking our feeding to attack again. After attacking or feeding to attack again. Declare UN called cool down time and set it equal to 1 days. Here it is. Okay. Since we added a level and ready time to our zombie struck in the previous chapter, we need to update the underscore get zombie to use the correct number of arguments when we create a new zombie. Okay. Update is only push line of code and end module level. Uh, and there it is. Correct argument. Okay. Update is zombie dot push and of code add two more arguments. One for level and okay, sorry. One for level and other is this one. Okay. So this value needs to be passed here. Note the uint32 is necessary because now returns a uint 256 by default, so we need to explicitly convert it to uint32. Now plus cooldown time is equal to the current Unix timestamp in second and plus the number of seconds in 1 day, which is equal to the Unix timestamps 1 day for now. Later we can compare to see if zombie ready time is greater than now to see if enough time has passed to use the zombie again. We'll implement the functionality to limit action based on ready time in the next chapter. So there it is, we have write the test. Let's check the answer. That's correct. So here we have completed chapter number 5. Let's move on to chapter number 6.